Well, I'll be the first to welcome you all, I suppose. I know there'll be some joining, so they'll miss out on this, but um, we have a whole group of us here from industrial engineering. I am Dr. Bernese, or Doc B. Try to be as informal as possible. Um, Morgan Kurla, Elizabeth Pearson, CJ Singleton, Maggie Stotzer, and Nevin Mendes. And hopefully we can convince you that of either industrial engineering is a good option or that you just cannot avoid us in any way, shape, or form when you get out in the real world. So, just a little bit of background about me. I'm going to lead things off and give the framework for what industrial engineering is. And the way that we do this is typically to assume that most of you don't know that much about industrial engineering, because that tends to be true. I know it was for me when I was sitting in your position. I'd never heard of it before, back almost 20 years ago. And so that's kind of the perspective. I also want to maybe expand, if you do know a little bit about industrial engineering, maybe expand your mind a little bit about what it is that IEs can potentially work on, areas that we have impact, whatever terms you want to say. Just I'm the director of academic programs in the School of Industrial Engineering, and all three of my degrees, bachelor's, master's, and PhD, come from different industrial engineering programs around the country. So, including Purdue, I am a Boilermaker. That's where I finished my PhD here, and so I hope that I'm going to provide a pretty compelling case. And if I don't, it's going to be awful because I really should know this stuff. So. Um, I like to start with kind of where industrial engineering got its start. So I like history a little bit. So I like to use manufacturing as an example. So as a discipline, industrial engineering really did evolve out of the need to make more stuff available to more people. So that's really what manufacturing is all about. Um, and so this is, as a discipline, we're about 100 or so years old, depending on how you measure it. Some form of industrial engineering has been at Purdue for more than 100 years, officially as a major since an undergraduate major since the 50s. And a lot of the early stuff that IEs did was really around the problem of how do you get um, a wider array of products, more complex types of products, or greater quantities, any number of types of questions around the making of things. And I like to use automotive as an example because it's really where my background started as an industrial engineer. But I also like to use it as an example because of how sophisticated this area has gotten because of the field of industrial engineering. And we're going to expand this out in a couple slides. But so if you may be familiar, there's an old phrase about Ford Model T cars. If you're familiar with classic cars, you'll obviously have heard of it. Even if you're not, you probably may have heard of it. But it was made for a long time before we started getting into model year type cars. The Model T was made for I don't know, something like 10 years or more, and they made about 27 million of them. And you could get a Model T in any color you wanted, so long as it was black. And they also only made a couple different varieties. There was a Model T truck, there was a Model T sedan, and there was a Model T coupe. And that was about it. And they looked the same pretty much from year to year to year. And Ford got really good at making them. But, it wasn't the, long-term solution as the other engineering fields and basic sciences matured. The ability to make more, to make stuff differently, to make more of it, and all that kind of stuff became sort of theoretically possible. But how to do it was and still is a really big question all the time in terms of engineering and science challenges. And so, in essence, basically, industrial engineers got their start by figuring out, can we make it more efficient? Can we make more of it? Can we better utilize resources in order to make it? And can we make it more personalized, and so forth? And so now, if you go to an automotive production line, the idea of making a single type of vehicle, and even within a single color, or other types of options and things like that, they can be made on the same line. So I'm using a Lexus as an example. You see a few different colors. If you were to look closer at these, you'd see different options. And some are at the level where they make multiple types of models, even on the same. So they could have a sedan, you could have an SUV, all on the same production line, one right after the other, in all different configurations. And the other thing that's changed about a lot of this is that the types of stuff that we make from them, the ways in which we organize it, has all become more sophisticated, has all become more flexible, so to speak. And so big questions essentially from an engineering perspective go to, how do we take materials and convert them into the things that'll eventually go into the cars? And so you take, you have plastics, you have metals, you have other, composites, and ultimately we need, at least in the case of cars, a few thousand different components to make this, the automobile work. And so getting that problem solved is one of the types of problems that IEs would deal with, because we need to be able to make sure that we are being resource efficient so that we can get it produced in the right quantities. Morgan? We also have to worry about what it is that we're going to do that with. And so another way of thinking about this, and a term that I'll use quite a bit, is transformation. And so, we're taking raw materials and we're translating them into components or other types of parts and so forth that they'll end up in the final thing that gets made. But we also have the transformation process. So what is the technologies that will make that transition, or whatever, I'm going to overuse the term transformation here, but that transformation happen. And so you've got milling machines, you've got 3D printers, you've got lots of other types of technologies that can potentially do these tasks. And so we have a lot of different types of materials. We have lots of different types of components and parts. We have lots of different types of technologies that can actually do the productive process. And we can stack another layer into this. In order to make the technology work, and to otherwise look at the broader scale systems issues that are related to these types of transformations, we need people. And so in some sense, I could have started with people, but I like the narrative I have a little bit better. But really, people are at the center of the types of systems that industrial engineers do. Types of systems that industrial engineers design and otherwise interact with, because nothing happens in some sense without this, people interacting with the system, operating the technology, collecting data, monitoring performance, and a whole host of other functions require people. So we have now materials, components, and parts, the stuff being transformed. We have the processes doing the transformation. We have the people who are interacting with the transformation process. And I've already given it a little bit of it away, but all of the stuff that we measure and understand about these systems, the data, the information, all of this stuff has to be coordinated and work together. So in a manufacturing line, we went from really simple at the early stages of the discipline to incredibly complex these days, and dynamic. In the case of automobiles, they change every model year. They may have changes in between. If you think about it, there's just a lot of transformation and adjustments and transformation and so forth happening every day or every month or every year. There's lots of different scales of time that we're going to look at these systems as well as industrial engineers. And so putting all this together, what we really do, and Morgan, you can move it ahead, is build out these systems with these four things in mind: the people, the processes or the stuff doing transformation, the parts, the components, the stuff getting transformed, the materials. And we can do this in any context. If you think about it, manufacturing is just one example of the mixture of those types of elements together. And if you expand it out, everything I'll still work with manufacturing here, but think about it. You have to get materials into the manufacturing plant, which requires transportation methods. You need trains and planes and ships and so forth. You need to be able to track and trace all of this stuff. So you need technologies that can allow you the type of information so that you know when you can do the production, when, how much of it you're going to be able to do, and so forth. And then at the other end of the process, you need some of the same types of technologies to make sure that you get the finished goods to the customer. And so you need to be able to interact with the companies that, like the retailers that will sell the final components. You need to be able to have warehouses and work with UPS and FedEx and all of these things. So you can just keep expanding this concept out. And so, like I said, I'm starting with manufacturing and I'm expanding it out from there. But if you think about it, how much of the stuff that you interact with is still a mix of people, a piece of technology, something that's getting transformed, and information. It's a lot of stuff. So let's add a couple more contexts here before I wrap it up. The key thing one of the key things I want to leave you with is a new term. Industrial engineering is a neat, compact way of defining the discipline, but it's not very descriptive. What makes industry industry, in some sense, is an open question. If you think about it, it's the mix of these four things together in a way that satisfies demand in some sense, human demand for different types of goods or different types of services and things of that nature. And so what we like to say is really industrial engineering is the design, improvement, control, management, et cetera, of human integrated systems. Like I said, people are really at the center. And what we want to do is make sure that we're building out these things with the needs of the ultimate, employees or workers or whatever term you want to use, and consumers. And so if you think human integrated systems, that's what we want to leave you with as a way of thinking about industrial engineering. So if you're interested in mixing these types of things together, this is really the engineering major where that's done as a core principle. And it's really the only engineering major that does that as in the broadest sense as a core principle. And so you can see and think of all different ways of mixing these things. And so you could have purely automated systems or it's technically nothing's really purely automated, but you have no people doing physical labor. And I've got an example of that with all robot arms. People are needed in other places in that system. Or you can have ones where they're working side by side doing the same types of productive activities or sharing the productive activity based on the skills from the automation side mixed with the skills from the people side. And so where you put the people, where you put the technology, and how much is a major design question in human integrated systems. We can move it ahead. And I'm really bad at clip art, so I'll describe this one more than what might be of interest to you. But let's say you were a company that operated in the US and you were making stuff, and you need to make sure that you can't make it wherever the person is. We haven't reached that level of complexity yet, although it is something that industrial engineers are working towards. But you can get pretty close, or you have to make the decision about how close you're really going to want to get when you make a product or you deliver a service. And so you need to be able to figure out, where do we make it? Where do we store it? Where does it end up after we've decided which consumer it's going to go to? So designing networks of facilities and resources, I'm just using the US, but it's really a global problem for the majority of companies out there, is also an industrial engineering thing. So if you think about the last slide, we're talking about work design in a factory as an example. It's a pretty small scale system. We're also able to talk about these same ideas at the global context. And so the level of analysis is also something that expands and contracts depending on the way in which we're looking at our human integrated systems. And I think that's pretty cool. The other thing that I like to finish with, and sort of setting the stage for industrial engineering, is that we look at solving problems often very differently than other types of engineers. We still need the same types of math and science knowledge and engineering science and so forth. But the idea is that when we're talking about these types of systems designs, or having impact on these types of systems, what we're really looking for is a business case in some sense. If I'm going to make something, I need to be able to sell it and make money, at least enough to be able to keep the operation going. But of course, the real, for the most part, most industry, the whole point of it is to essentially make money so that everybody benefits, in a really rough, broad way of saying it. So what we're doing is taking these designs and evaluating them as a business case. If I want to design, for instance, going back just to a couple slides, you don't have to go back, Morgan, but if you were to remind yourself of those slides, we're trying to design that space that will do that production. I have to be able to say that every time a product comes through there, I know how much it's going to cost, I know how much I can sell it for, and so that that I can make it affordable for whomever wants to buy it. And so, our engineering design process connects very directly to the ability to actually create and sustain business. And it's not simply can it be made, which is often the question, and is a really awesome question that other engineering majors get to ask or focus on. Can it be done? We're asking, can we make money with it in some sense, a product or a service and so forth. And so the other thing I want to, add to this in some sense, before rounding it out, is if you think about the elements that make up what IEs work on, the things that constitute human integrated systems, you have information and data, you have people, you have technologies, you have the different materials. There's so many different varieties of each. There's so many different types of people out there with different skill sets, different interests, and so forth. You got to be able to design work for them. To understand how a system works in order to know that you're going to make money with it, or that you can manage, you can always, in the case of products, have a high quality product that is basically the same every time somebody wants to use it. There's different types of information that can be brought to that process, that decision-making process, or that analysis. There's different types of materials out there, plastics, metals, like I said, composites, and so forth. There's different, every one of those things has probably different configurations that could all work, but we're always asking what is the best one that we could possibly do. And like I said, we look at that in terms of money. And so what this allows us to be is really the type of person who could work on the the strongly technical side, or you could work on the more business oriented side, you could work on somewhere in between. And that allows us to have a breadth that is really highly regarded in industry, which is why, although industrial engineering is not necessarily well known, it's actually a really large discipline, and impacts a lot of different types of places. And if you look at where our students get hired, these are examples of companies that have been doing quite a bit of recruiting over the last few years. You see a huge variety in context. You've got information technology, pharmaceuticals, industrial automation, heavy equipment, automotive, healthcare, experiences. That's how I like to describe Disney. You've got consumer packaged goods, you've got consulting, you've got travel and logistics, and so forth. And so all of these are mixes of human integrated systems. They have different emphases and so forth, so they use IEs differently depending on the needs. But this is just a sampling. So I wanted to give a little bit more detail. So I picked some of the roles these are actual roles that our students have taken, or alumni technically. I didn't include interns in this, but our alumni have had in these organizations, ranging from relatively recent hires through longer term career roles. And you see, again, a big mix of application areas, because when you start to look at organizations and you start to look at human integrated systems more broadly, pretty much everything that happens in industry is a type of a human integrated system and could use the type of skills that IEs have. And so you'll see things in finance like compensation. You'll see stuff that's more strategic, resource oriented. Now, that might not necessarily mean anything to you, but if you think about business transformations, so completely restructuring, the way that an IT system works within a business is a massive engineering project. And so how to allocate resources in there is something like a director of business transformation might do. And so that's a little higher. You have just some more of the traditional engineering type roles. You saw sales engineer or manufacturing engineer or reliability engineer, all the way through to things like, C-suite level roles, chief marketing officer. You have directors, and you have senior vice presidents and so forth. And so IEs tend to migrate to these business leadership roles because of the ability to work around and inside of these types of systems. And so, if you want a really diverse career, or you don't know what you necessarily want to do, but you really want to have the analytical mindset, and again, industrial engineering may be a spectacular option for you. And at the very least, like I said at the beginning, you're going to realize you just really can't avoid industrial engineers when you get out into practice, because, if you have another engineering major in mind, that's spectacular. We need way more engineers in the world than we really have. And then that we'll probably ever have. But you know, once again, that question of getting from can we do it to can we make money with it, that's really the domain of industrial engineers. And then again, to add one more layer to it, to ensure the continued success of these types of systems as people change and technology changes, and you know, the elements that make up this human integrated system change and adapt over time. Industrial engineers are uniquely trained to be able to manage that process over long periods of time. So this is essentially my version of industrial engineering in a nutshell. I know I've covered a lot of ground very quickly, but you know, like I said, if the complex mix of diverse types of things like materials, information, people, technology is something of interest to you, industrial engineering is really a spectacular place to practice the skills in those areas, or to develop further skills in those areas. And so I would strongly encourage you to take a look at it. I think this is my last slide. Yes, it is. Unfortunately, I can't stay. I have another thing at 5:30, or sorry, 6 o'clock that I have to get to. But it was a pleasure. If you want to talk to me later, you can. You can reach out. Well, my first initial and last name is one word at Purdue. You can always look me up on the IE website. I will leave everybody else to it. Thank you very much.
Thanks, Doc B. So Doc B covered sort of the overarching discipline for like what industrial engineering is, and what we'll talk about is more of the intricacies related to Purdue. So first thing here is just kind of looking at the courses that are in the plan of study. There are sort of different umbrellas that kind of fall under IE. Doc B kind of covered manufacturing and what that looks like. There's human factors, production and systems, and operations research. And the goal of our curriculum is to make you that well-rounded IE student. So you have courses in each of these areas. Human factors focuses more on the sort of design and decision-making, or I guess cognitive aspect of things. Production systems, dealing with sort of supply chain type concepts. Manufacturing of goods, as well as operations research, bringing in that analytical piece. IE is probably one of the more math-oriented disciplines than, or math and numbers, than probably some of the other majors that may be more based in physics and things like that. So we've got courses that support the plan of study with probability, statistics, economics. And then one thing that is really cool about our curriculum with the IE classes, you are required to take other engineering courses as well. But the senior design capstone is probably students, one of their most favorite classes, just because it is sort of the culmination of your experience working on a real industry project. So you get to kind of apply everything you know at that point. So the curriculum definitely gives you that strong foundation in each of those areas. And then if you have a particular interest, you can take that further through some of your electives. And then there's a variety of opportunities that relate to those areas within the curriculum, as well as are complemented by minor certificates, specializations, and sort of other as listed there. So I would say quite a few of our students have minors. Management, statistics, economics tend to be one of those more common ones, but really a lot of them can align with IE. So a few sustainable engineering, communication, languages, psychology. There's nothing that's really off the table. Certificates, data science is one of those emerging areas. There are coursework related to healthcare, engineering, and then we do have one specialization within IE that is software focused. And then other experiences that kind of complement our undergraduate research, co-op, gear, and then it's very easy to study abroad for IE students. So that kind of segues really nicely. So basically, our general philosophy related to global experiences, if we can make it work in your plan, we will do whatever we can to get the coursework. So there are a variety of different avenues to study abroad. There are summer programs, full semester exchange, maybe fall or spring, and then sort of short-term programs as well that could be summer or spring break, and things like that. So lots of partners in Asia, South America, Europe, and basically if studying abroad is something that you're really interested in, the coursework that you'll see will vary at different locations as well. So some locations are more in alignment with what IE is at Purdue, and others are a little bit more maybe entrepreneurial or systems focused or things like that. So you'll see a variety of, I guess, interpretations of IE from a global context. And moving on to leadership and professional development opportunities, we've got a few organizations that are connected to this school. IISE, which is the Institute for Industrial and Systems Engineers, is probably our largest organization that students get involved with, and Nevin can talk a little bit about that. He's one of the ambassadors for the organization. But it's really great to connect with sort of your peers in the school. If you've got any interest in healthcare, human factors, there are organizations for that. The symbol in the middle is Alpha Pi Mu, which is the IE Honor Society. And then consulting is another area within IE that is sort of developing in the sense of basically IEs using their skills to help other organizations problem solve. So Purdue Think and Purdue Solutions do that at varying levels. So other student experiences. So we've got students that participate in the Certificate for Entrepreneurship and Froyo Express and the Yumi Backpack were both products of that. But we've seen other students kind of start their own businesses while they're an undergrad, and IE has kind of given them that framework and support to do that. IEs are highly sought after at different career fairs. So internal, we have our own IE career fair, one in the fall, one in the spring. So about 75 companies between those two. And then industrial roundtable, we're one of the larger majors that are recruited overall. And then the Krannert management career fairs as well, just given the sort of management and engineering skill set. We also really believe in alumni engagement within IE. We want you to connect and hear the stories directly from the people that have gone through this program. All of us advisors are not engineers by background. We've kind of learned the ropes interacting with the IE alumni and sort of being in the department, but hearing those actual stories is really nice to sort of create those networking opportunities. And then there are also professional development opportunities sponsored through the clubs and organizations. There is a Greenbelt certification, there's company networking nights. So lots of opportunities to help you connect and grow as a student. And then I'll finish up here with just some numbers. Our undergraduate program is ranked #2 in the nation. We are also the second largest IE program in the US, sitting at just under 800 students. We've got sort of a split of male and female ratios, and we are one of the higher engineering majors for female students, so about 30%. Domestic international students, and then I guess Grissom Hall isn't a number, but we are located in Grissom Hall. That is our home, one of the recently renovated engineering buildings. So definitely stop by and feel free to reach out to us. We're happy to chat. So enough from me. We're going to move on to our guests with us. So Maggie is an alum of the school. She graduated in 2017, and she is currently an operations program manager for Azure at Microsoft. So I'll let her sort of tell you about her experiences and why she chose IE.
Sure. Thanks, Morgan. So, hi, everyone. My name is Maggie. So, like Morgan mentioned, I graduated in 2017. I started my career at PwC. So, I kind of went the consulting route that both Morgan and Doc B talked about. I was a technology consultant for PwC, and I focused on cloud migrations, IT disaster recovery, and large complex system implementations. And then most recently, I transitioned over to Microsoft full time. And now I'm a portfolio, my title kind of varies depending on who you ask, but I'm an operations program manager and basically a portfolio manager for all new launches on the Azure platform. So I guess a little bit about why I chose IE. I think like what Doc P talked about, kind of the foundation of industrial engineering is based on optimizing systems and processes. And that is super versatile across a number of different industries, a number of different types of roles. So I think that's what I was initially drawn to. I knew I wanted to do engineering, and I was sort of between like ME, Chemi, IE. So that was a plus in the IE department. And then I think another thing that Doc B sort of talked about was that the industrial engineer in the most traditional sense, manufacturing, is kind of like the jack of all trades. Like they're responsible for coordinating with all the different people and teams to help improve processes or systems. And one of the things that Morgan mentioned is IEs, we take a number of classes in the other engineering disciplines. So that the IE is kind of that person that can speak the language of the other engineering disciplines and coordinate across them, which I thought was super interesting. And then lastly is just kind of the breadth of career options that Doc B showed. I mean, you look at that slide and you can go into healthcare, consulting, or manufacturing, technology. I have kind of taken the technology route since I graduated, but a number of other people have gone other routes. And I think the unique thing, and this isn't necessarily unique to industrial engineering, but it certainly applies, is that most of my friends like their jobs. Like you always hear about people complaining. You go on Instagram and there's all these memes about people hating their jobs, but I can say I personally really, really like my job. And I think that goes for a lot of my friends that are in engineering and specifically industrial engineering. So that's a little bit about me. I'll hand it over to you.
Clubs or organizations that you were involved with, Maggie?
Oh, yes. So I was in IISE, I was in Greek Life, I was a TL for BGR, and then probably most notably, I founded Purdue Solutions. So Purdue Solutions is one of the consulting organizations that Morgan showed. After interning at PwC after my junior year, me and one of my friends who also interned there, we spun up Purdue Solutions our senior year. Kind of one of the things that we noticed was our friends from the internship at different campuses had consulting outlets that gave students real world consulting experience. And that was kind of a gap at Purdue. So we spun that up senior year, and it has continued to grow, which is great. And I still have pretty close ties with the organization. Nevin is in it, and I've met Nevin before, and we do a ton of events with them.
I guess that's the perfect segue. I didn't know you guys were connected. So
yeah,
Nevin, you're up next. Let's hear about your experiences.
Yeah, so I'm a junior in IE, and like Matt said, I've been really involved in a couple of clubs in IE, especially ISC, which is why I'm here right now. But the one nearest and dearest to my heart is Purdue Solutions, like Maggie said before. And that, I think, is one of the most important factors of IE, is that it's really a family and you get to know so many different people, and just getting those networking opportunities with role models like Maggie and upperclassmen that you get to meet through classes and clubs is something that I've really tried to take advantage of, and that any student really can do. And it's really helped me shape where I want my career to go. So also kind of following Maggie's footsteps is I kind of want to go into consulting. So a lot of the experiences I've had through IE at Purdue and also my professional experiences in a federal contracting firm and a third-party logistics firm has been around me wanting to get to that next step in consulting. And I think that's kind of unique to industrial engineering in that, and one of the reasons why I picked an IE is that you can go in so many different directions. So whether you're kind of stuck right now as a freshman and wondering where you're going to be in 5 or 10 years, IE is such a perfect route to go because you can go, like Doc B said before, in supply chain, consulting, manufacturing, healthcare, whatever it is, there's a place for IEs to go. And for me, coming into college, just knowing I liked engineering and business and statistics and not really knowing specifically what I wanted to do with my life, IE was really perfect for me because, again, like there's so many opportunities to learn in classes, but also get involved in your extracurriculars and get to meet people that will help guide you and just help you focus on where you want your career to end up.
Thanks for sharing that. I guess one thing I'll add in terms of IE as well is it really is industry engineering. You can really go in any direction related to, I guess, whatever industry. IEs are needed in all of those in terms of efficiency, problem solving, and sort of cutting costs and things like that. So the curriculum really does give you that toolkit to solve those large scale system problems, which I think makes it very unique compared to some of the other majors. I think of statics and aero, thermo, and it's like, okay, you have this equation to solve this problem. When you're solving human problems, there's not always an equation to give you the answer. So IE gives you that toolkit to kind of look at things super broadly. So kind of last slide, and then we'll open it up to questions. There's just our information. So Elizabeth, CJ, and myself are the undergraduate advisors. We're always happy to chat. If you have questions, you can also make appointments in Boiler. Connect with us if you are not currently in IE, or if you have questions, just send us an email and we'll connect with you. We do have a YouTube page with lots of alumni spotlights and videos to kind of give you additional perception related to IE. And then we are on different social media platforms, Facebook, Instagram, Twitter. So any way you want to reach out and connect, there are definitely avenues to do that. So questions. You're welcome to unmute yourself or put them in the chat and we will answer them. So you can direct them towards, I guess, any of the 5 of us. I guess I'll ask a question to both Nevin and Maggie. Did you both know about IE before coming to Purdue, or was that something you stumbled upon?
I did know about it. I had done a bunch of research on the different disciplines before I came to Purdue, so knew a little bit about it, but you don't fully grasp it kind of until you start connecting with people at Purdue.
It was kind of similar as well, but in high school when I was doing research and knowing that, like again, I wanted to go and learn more about engineering and business, but also knowing that statistics was always my favorite subject in high school, just knowing that that intersection was always available in IE was something that kind of stood out to me. So I actually knew going into freshman year that I wanted to do industrial engineering, but going to events like these and getting to know upperclassmen and people in clubs really helped me confirm like IE is definitely the best route for myself.
So you got one question that might be, I guess, more relevant for you guys because you are IEs. What is a typical day like?
I guess I can answer that being in industry. So a typical day, I can kind of talk about two different ways since I started with PwC, but in the consulting realm, a typical day looked like I was assigned to a client. Typically, the client engagements lasted anywhere from 2 weeks to 2 years, depending on the scale of the project. Typically, there's quite a few meetings, so you spend a lot of the time interacting with the client to understand what their problems are. Typically, they end up breaking the project into work streams. So you're assigned to a work stream, you've got a specific process or part of a system or scope of a system that you're responsible for building out the requirements for, working with across engineering and business to get it implemented, build out the manual processes. So a lot of meetings on clarifications, putting together documents. I mean, what I did was a lot of large scale system implementations. So I think that's kind of the perspective I'm giving there. And then kind of in my newer role at Microsoft, a typical day looks more like I'm overseeing the portfolio of launches in the Azure space. So anything that's new, from like a new feature that's coming out for Microsoft partners or a new product that will be available on the platform, that launch kind of rolls up under my portfolio. So I spend a lot of time working with the project managers or launch managers, as we call them, and understanding where they stand, where we are with requirements and working with engineering, and then kind of bundling all that information together and reporting it up to the execs.
Cool.
And I can talk a little bit about the classes that you'll take and just like your regular student life. I would say there's a large mix of, just like I said before, like your classic engineering classes. So you'll take thermo and statics and dynamics, and you also have that mix of statistics classes as well. So IE will give you probability, statistics, and then also what I really like is the business classes that are in there. So engineering, economics, operations research, and you really get a lot of everything every semester, which I really like, just knowing that every subject is very different from each other, but it all kind of ties into what the type of things that you can do in your work and in your internships. And the internships I've had so far is kind of similar to what Maggie has said. It's just the fact that you're always going to be working in cross-functional teams. Like last summer, I was doing a software implementation, and I was working with everyone from IT to finance to the people on the floor. So a lot that goes into the client-facing aspect of IE, and I think that is prevalent in a lot of different roles that you could take on. But as a student, I would say you get a lot of variety in the classes that you take, and then you also have an opportunity to get involved in clubs that will also keep you busy throughout the week and weekends.
Yeah, so we also have another question that was talking about field work. How much field work is there in IE? I can address that one a little bit if it's just related to like internships and things like that. A lot of, I mean, internships are not required for IE as part of the curriculum, but definitely our students seek those out pretty heavily. So a lot of the, I guess, the field training is on students aside from what is given in their classes. Our classes definitely have, once you get to the junior year, a lot more group work and projects. So you get to learn how you interact well or maybe not well with others. And sometimes that's the biggest learning thing, just learning to work with others who have different styles from yourself. But nothing really required in terms of field work, but there's no shortage of opportunities. Other questions? Like I said, you're welcome to unmute yourself and ask those. So I guess I'll ask one of our guests as well. What are your thoughts on grad school? Is that something that you're considering in the future?
So I have considered it. I think if I were to go to grad school, I would go the MBA route, just based on kind of the route that I've taken post graduation. I know a number of people are interested in that, but I've got friends that have gotten like masters in supply chain or masters in IE, and it certainly adds another layer of expertise. So it's worth exploring. I think it kind of just depends on which career path you go down.
What about you, Nevin?
Yeah, and for myself, a very similar outlook. If I were to do another degree, I would definitely consider business school. And it's something that I'm definitely thinking about later in the future, just because of the roles and the type of companies I want to work for. But like Maggie said, a lot of my friends are considering doing another master's degree in whether it's in IE or economics or math. There's a lot of different routes that you can take, but for myself, business school is pretty much the biggest grad school that I'm thinking of.
Cool. And then I guess this next question I can answer in terms of sort of internships for international students. I think it really just depends on the companies that are able to sponsor international students for internships. I know that can definitely be challenging because there's significantly less companies that sometimes have that ability, but I know that international students usually have a pretty good go for IE, just given how broad the discipline is. You're not sort of pigeonholed into sort of specific positions. So I think IE can be widely interpreted to what relates to the field of study for CPT and OPT. So this might be good for our guests. So how much science and math are heavily used in IE? So do you use any of your sort of pure math or science courses?
So in my path, not really. I mean, there's certainly like a good amount of data analysis, and I would say that's where you use some of the math, although the data analysis isn't like differential equations. It's like, what's the average of the cost for the whole year? So the math science, the consulting route probably is not quite as applicable, but if you go the more traditional manufacturing route, I think it's very applicable.
Yeah, and my comment earlier saying math is more of or IE was one of the more sort of math and numbers oriented disciplines. You take linear and DiffyQ, and those kind of feed into your operations research classes, linear programming and sort of stochastic modeling, using those foundations, but you're not necessarily sitting out there doing out math equations. Although I would enjoy that because I was a math major. Maybe not DiffyQ, but but math for sure is a foundation in some of those pieces, but not sort of the culmination of everything. Are we sort of out of time at 6:20, Andrew?
Sorry, I couldn't find my mute button.
You're fine.
I can hang on for a few more minutes. I have another session at 6:45.
Okay, yeah. We're happy to hang around for a few minutes if anyone wants to ask any more questions, or our information is on the IE website as far as the advisors. And then I know Maggie is on LinkedIn, so you can reach out to her that way, as is Nevin. So we hope that this was informative, and if you have any interest in IE, just let us know. thank you, Nevin and Maggie, as well for joining us. We
Of
appreciate
course.
your
you.
time. We know that you're busy with classes and work and sort of work from home life.
Anytime.
All right, thanks everyone. Appreciate it. Hope you choose IE.
Nice to see you again, Maggie.
Yeah, you too, Nevin. Bye.
Bye.